Hey everybody, this is the Test 1 review assignment. I've picked some of the problems, not all of them, but because some of them are very similar but copies, so I've just chosen like one in that case, and I wanted to work through some for you. Okay, so let's start with the first one. And this review assignment is found in MyMathlab. Remember, it's an assignment that helps you study for your test. It's not for any credit, it's just to help you study. Okay? First, convert the given radical expression to the rational exponent notation. Okay, so the rational exponent means you're going to take 2x plus 7 and you want to raise it to an exponent. So whenever you have a root, in this case it's the 11th root, you can write it as a power or an exponent as 3 over 11. The 3 represents the cubed, right there, and the 11, which is the root. The 11th root is what is always in the denominator. But when they ask for the rational exponent notation, this is what they want you to type in. Okay? This is what we want you to type in. Now the next one is just going backwards. They give you the problem in rational exponent notation, and they want you to write it as a radical. Radical is just another word for that square root sign or that root sign. We call it a radical sign. So we would write this. You have 3x plus 7. All right? So, first of all, it's squared is to the 2 over 7. So that's the 7th root. Okay, this is your answer. Let's see. Circle it. That's your answer. Real quick, I just want to, when looking at these two problems, one of the common mistakes people make is for the second one, this would be wrong if you wrote it like this. Right, to the 2/7. Sometimes people want to do that, but they fail to put the parentheses. If you put it this way, it's incorrect, because this, the way you've written it, is only raising 7 to the second power, but it's got to be the whole thing to the second power. And the same thing for the first one we worked. Sometimes people want to write it without the parenthesis. So if you did that and you wrote it like this, right there, I've seen this in the past. You're getting the right idea, but it's incorrect, because in this way you're only raising 7 to the 3/11th power. You've got to put the parentheses. So just be careful on that. Okay, now let's go to the third problem. Rationalize the denominator. Okay, so remember, rationalize the denominator simply means we want to rewrite this to where there's no square root sign in the denominator. Okay, and the way we do it is we use the conjugate. So what we're going to do is, we notice in my denominator we have 2 minus the square root of 3. We can use the conjugate, which is 2 plus the square root of 3. So remember, it's the exact same thing, just a different sign. Right? And if we multiply the bottom or the denominator by that, we have to multiply the top by the same thing. Right? So basically we have multiplied our original fraction just by the number 1. So we haven't changed the ratio. Okay, so to rationalize it now, for the top, there's no need to multiply this out. Let's keep it like this for now, with the hopes that maybe something simplifies. And in the denominator, we're going to FOIL this out, but it's a difference of 2 squares, right? So when we multiply the first, which would be the 2 times 2, if you have the outer, which is the 2 times square root of 3, you get 2 square root of 3. The inner terms is the 2, right there, 2 times a negative square root of 3, right, which gives you that. And then finally, the last two right there, square root of 3 times square root of 3 is just square root of 9. So minus square root of 9, which is 3. So let's simplify it. Okay, let's recopy this. In the denominator, we have 4. If you notice, those just subtract out to give you 0, which it should happen every time if you use the conjugate method that we're using. And then the square root of 9 is 3. And so see what we have? We have no more square root in the denominator. 4 minus 3 is 1. Okay, sometimes you could get a problem where this is actually a number besides 1 in the bottom, in the denominator, and you can cancel with the number 3. So you can look for that. But my final answer would be 3 times 2 square root of 3. No need to write 1 in the denominator since it's just 1. Okay, let's move to another problem that is just like the last one we worked, except this time I'm asking you to rationalize the numerator. Okay, I'm going to zoom in a little bit just to make it a little bit bigger for us. Okay, rationalize the numerator. This time I'm trying to focus my numerator, and I want to get rid of that square root sign in the numerator. So we're going to use the conjugate method again, okay, which means just take the conjugate of the numerator in this case, because that's the one we're trying to rationalize. All right, so if I multiply by that, I've got to multiply the top and the bottom, right? Our numerator and denominator by square root of x minus 3. Okay, so now in this one, only multiply out the one you're trying to rationalize, which would be this numerator. I'm going to change the color. So we have square root of x times square root of x equals x, or x squared, square root of x squared. We have the outer, it's x. We have the inner, which is plus. See, those should add out to give you 0. And then finally, 3 times negative 3 is negative 9. All right, go back to black. Okay, so notice those give you 0, right? And I'm just going to recopy the denominator. This is why we didn't want to multiply this one out, because as you can see, we get x minus 9 in the numerator. We happen to have an x minus 9 in the denominator, which can simplify. Okay, so that's why it was nice not to multiply the denominator out. And your hope is that maybe there's something you can cancel. So once you've canceled it, your final answer, don't forget, that leaves a 1 in the numerator. And there we go. We have rationalized the numerator. Now, yes, there's a square root sign in the problem, but it's in the denominator. My question was wanting you to rationalize the numerator, and we successfully did that. All right, so that's rationalized. So there's one. The one before was rationalize the denominator. This is rationalize the numerator. They're worked the exact same way. Okay, now we just get to factoring polynomials. This one they have a few in the review assignment about factoring. So let me go in here. They just want you to factor the polynomial completely. Notice this is not an equation. This is before we got to solving equations. They just want you to show that you can factor it. Hopefully by now, with the problems we've worked, you can recognize that this is a difference of 2 squares. We know that 9 is 3 squared, and 25 is 5 squared. So we could rewrite that. 3 squared minus 5 squared. Or you could just recognize it. But when you have a difference, which is subtraction, difference of 2 squares, which it is, then we can factor it very simply. 3x is my first term in both of them, and 5 is my last. 1 is positive, 1 is negative. Doesn't matter what order. That's all they're asking for you to factor, so you don't need to solve the equation. There's no equal sign in there to solve for. They just want it factored. Okay, so those are those two. We'll move on to our next page. Now we get to solving equations. These are just basic linear equations. This particular example has just got y in it instead of an x, just a different variable. But we're going to solve for y. So let's just work it out. We're going to start by distributing through 9, 3, and then the negative 2 can distribute also. So okay, this looks like this, let's see, 9y plus 9. Let's see, 3 plus 6 is 9, right, minus 2y. All right. So let's add, I'm going to bring 2y to the left side. How's that? And then I'll take minus 9 to the other side. All right, what does that leave us? Let me go back to black. That leaves us 9 plus 2, 7y, 0. And this is all 0, isn't it? Looks like it. Okay, so last step, divide out by 7. we get y equals 0/7, which is the number 0. Okay, this one happened to turn out to be 0, but clearly you could get another number besides 0. But it's just being able to solve basic linear equations. Okay, now let's solve the linear inequality. The only thing really different on this one, is we want to write our answer in interval notation. So let's work it out. We have 2 times x, 2 times -1. You work it just like you would a regular equation. Just except when you divide or multiply out by a negative, that's when it's different. Let's combine our terms. 2x minus 4x is -2x. Here we go. All right, what do we want to do? Let's bring x to the left side. So this will be -3x. And let's bring 2 to the other side. That'll give us 21. All right, I'll go back to black. Okay, so we get down to this part. Our final step, we have to divide out by -3. Remember, because we divided by a negative number, right there, we have to change the direction. Those cross out, we get x. We change the direction. Is less than or equal to -7. Okay, that's our answer. But they do want us to write it in interval notation, right there. So you don't have to draw it out, but let's draw it out just to help us. X is everything less than, right? So it goes to -infinity. But right here, remember it's less than or equal to. Remember, equal to is the same thing as saying a closed dot, which is also the same thing as a bracket. So I'll do it all of it, okay? So if you're going to write it in interval notation from left to right, or least to greatest, it would go -infinity to -7, right? Parenthesis on the negative infinity. Make sure you put -infinity if it's in the infinity direction. There's always a parenthesis, and then there's a bracket at -7. And once again, that was simply because we included the equal sign in the less than or equal to. This is what we want you to put in, type in for your answer. Okay, here we have a double inequality, or sometimes it's called a compound inequality. Let's solve this. Now remember, with a compound inequality, our goal is to get x by itself in the middle. Okay, so let's work it out. Our first step, if we're trying to get x by itself, you have a denominator of 2. We want to get rid of the fraction first. Always we want to try to do that first. We can do it by multiplying everything by 2. So I'm going to multiply, I'm going to multiply every side. So I multiply that by 2, I multiply the middle by 2, and the right by 2. By doing that, these two cancel, right, which is what we wanted. That gives us 22. 3x plus 1, and 34? Okay, you didn't have to worry because you were multiplying by +2, so nothing changed, no directions changed of the signs. So you're still good. Okay, so now we're still getting x by itself, so let's clear 1 to all sides. So we're going to subtract 1 from all three parts. That gives us 21, 0, and 33? Okay. All right, finally, we're left with this. We want x by itself, so we can divide out by 3, and it's just a +3, so you still don't have to worry about changing directions of signs. So by doing that, I'm going to write the answer. I'll do it up here. We get 21 divided by 3 is 7x 11. Okay, so it kind of worked out nicely. So in interval notation, if you were to draw it out, which if they don't ask you to, you don't have to, x is everything in between. That's the easy part. Just make sure at your end points you get the right thing. So because it was equal to, over here at 7, we include it, which is a closed dot. And because it's strictly less than but not equal to, that's an open dot. Okay, so my answer would be 7 to 11. Closed dot is a bracket, open dot, parenthesis. This is what I want you to type in for your answer. All right, so now we get into solving quadratics. Remember, quadratics are when you have variables that are squared. If you notice, this one right here, v squared, it's a quadratic. Okay, so when we're solving by factoring, your first step is bring everything to one side, including that 20, set it equal to 0. So make sure you do that first, then try to factor. When it tells you to solve by factoring, it ought to factor, so you know something's going to work. We have 20 is what, 10 times 2? Minus and plus. And that works. Once you have it factored, just set each individual factor equal to 0 and solve. You get two possible answers. I get 10 and negative 2. Okay, so in Pearson, when you're filling this in on the test, it'll be like this and just leave a spot, so you can just do 10 comma negative 2. And it doesn't matter what order. Okay, that's solving by factoring. Okay, we have another solved equation by factoring. I just decided to put 2 on here. This one is already set equal to 0, so let's just factor it. We have 3x times x, and then we have 5 times 1. It's just we want to get the right order. I'm going to put 5 and 1 like this, plus and minus. You can always check yourself. Remember, I don't know if you see this, but this is the way I check. You can check to see if you get 14x. That's the hard part. You can multiply the two inner. It's like the full method. This is the inner part, the I part, and then the outer. 3 times 5 is 15x. These should add to give you, right, your middle term. So since I have the right term, I know I have it factored correctly. Okay, that's just a quick way of checking. Sorry, let me go back to black. So once you do, of course I could erase all that. Let's see. I'll erase it real quick. I'll make it a little bit bigger. And we can solve it. Okay, that gives us 3x minus 1 equals 0 and x plus 5 equals 0. We get two possible answers. This, if you solved it, would give you x equals 1/3. And this one would give you negative 5. Two possible answers, 1/3 and negative 5. All right. Okay, so we go on to the next one. Solve by using the square root property. This is just another way. Now, I will say, when I'm checking your notes on your test, I do want to see that you're using the square root property to show that we know how to do it. Okay, let's see. For the square root property, we have the x part that's squared. We want to isolate that by itself. So let's start by taking the 1, clear it to the other side, so we'll add it to the other side. Square root property says that you can actually take the square root if it helps you solve the problem. You just have to do it with both sides. So if I took the square root of one side, I have to take it of the other side, but you cannot forget to include the possibility of the negative value. So you have to do plus and minus. There's two possibilities. So over here on the left side, the square root, which is kind of an understood 2, it's just never written, of 2 squared, those cancel and just give you x minus 9. That's what makes this process so great. It's a quick way to get that x out from underneath the squared. And then you have plus and minus square root of 1, which is just 1. All right, so we solve at x. I'm going to add 9 to the other side. 9 plus and minus 1. So let's go ahead and finish that. That's saying that's 9 plus 1 and 9 minus 1. We get two possible answers, 10 and 8. Which, when you get a whole number like this, that means from the very beginning, you could have multiplied this out and it would have factored nicely. But that's not the square root property. And you never know for sure if it's going to factor, because a lot of times your answer is going to have a square root in the problem, in the answer. So this is just a nice quick way to do it. Here's another square root property. This is just kind of a small one. Using the square root property, we want to take the square root of that x squared, but you don't want to do that until it's by itself. So our first step, let's clear 3 to the other side. And since you're multiplying, you can divide it out. Get x squared equals 5. All right, so now let's use, I'm going to do it over here. Using the square root property, you can take the square root of both sides. Do not forget plus and minus. So I get x equals plus and minus square root of 5. You know, possibly you may have to type it in as positive square root of 5 and negative square root of 5. You know, you can try the plus and minus. I'm not sure how Pearson will take it if they'll assume that's incorrect. Okay, for our next one, it says solve the equation. If you notice, it doesn't tell you what to use. It doesn't tell you to solve by factoring or something like that. So in this case, your first method that you're going to try and hope that it works is by factoring. So looking at this one, looks like we can factor. I'm going to zoom in. We can take a 4 out, and we can take a c. If we do that, we get c squared, 2c, and 4 goes into 140 35 times, so that gives me 35, which it does factor, which is great. Well, that the hope is, of course, but this last little polynomial here, it does factor, because 35 is 7 times 5, and 7 minus 5 is 2. So it does factor. Okay, and once you've factored, notice there's 3 factors. Set each one equal to 0 and solve. You can look at these a lot of times and tell. You don't necessarily have to write this step right here. I realize you can kind of look at it and tell. The first one would be c is 0. The second one would be negative 7 and 5. Notice we get 3 possible answers. Our original problem was c cubed, so a lot of times that happens when you have c cubed. It means you could have 3 answers, 3 or less. Now look at this one. If you notice, solve the equation after making the appropriate substitution. These are the directions that are listed in Pearson. For this case, you don't necessarily have to do the substitution method, okay? Matter of fact, I'm really not going to. Now, just like the last one we talked about, when you see x to the 4th, that means that we could very well have 4 possible answers, 4 or less. But to approach this problem, let's first see if it factors, and it does. Here we go. In this case, because we have x to the 4th and then x squared in that middle term, I can actually factor it by using, just like we would factor a polynomial using x times x. This one we're going to do x squared. That multiplies to give you x to the 4th. And let's see, 160, looks like we could do 16 times 10, because 16 plus 10 is 26. Okay, so we need negative 26, which means we got to have negatives. So it does factor x squared minus 16, x squared minus 10. Okay. We were able to figure this out without substituting, okay? We just were able to use the x squared. That's how we would approach this one. So let's set each factor equal to 0. Notice it's an x squared. So please don't make the mistake. This is not x equals 16. This is x squared equals 16. So to solve this, you have to use the square root property. Let's clear 16 to the other side. So to get x by itself, you can square root both sides. Do not forget plus and minus. It gives you 2 possible answers. X equals positive and negative 4 plus and minus. That's 2 answers. Same thing for this one. Let's clear 10 to the other side. And you can use your square root property. Plus and minus. We get x equals positive and negative square root of 10. Okay, those are 4 different answers. So when you're typing in your answer, has x equals, and it just gives you a blank, you just need to do plus 4, negative 4, square root of 10, and negative square root of 10. That's how you'll type it in. All right, and that is my answer. I've just seen too many people, when they miss this, actually factor it correctly, but when they solve it, they solve the x squared like it's x, and they might put x equals 16 is their answer, 16 and 10. They fail to solve it for x and use the square root property. So just be careful on that. X to the 4th means 4 answers. All right. Okay, let's go. Complete the square. let's do this one. Okay, so for this one, you know, a lot of times in the homework, you might have come across some that have a multi-part question. So this one, notice it just says solve by completing the square, and they just want you to give the answer. So let's just make sure, if I'm asking for complete the square, I mean I want you to do it by complete the square, okay? Yes, the quadratic formula would give you the same answer, but I'm wanting you to show that you can use complete the square. Okay, so let's just do it step by step. First step, clear our constants to the other side. So I'm going to clear 2 to the other side. All right, so we got to figure out what we're going to add to both sides. Remember, you take the 8x, half it, you get 4. All right, just divide it by 2 and get 4, and then you square it. So we're adding 4 squared to both sides, which is 16. So we've created a perfect square on the left side right there. I'm on this left part. Remember, then you can immediately factor this thing, into something squared. That factors into x minus 4. Okay, so that came from red. X. The minus in front of the 8 is the sign that you use right there, and then the 4 is the number you got when you halved the 8 before you squared it. So that's how it factors. And that leaves us, 18 on that side. Okay, that's completing the square. We created a perfect square on the left side, and then we turned right back around and we factored it, and we put it into the form x minus 4 squared. Now once we have that, all that's left is we know how to solve this. This is using the square root property, so let's solve that way. You can take the square root of both sides. Don't forget plus and minus. The left side cancels. Just gives you x minus 4. We have square root of 18 on that side. Let's add 4. We get 4 to add it to the right side. 4 plus and minus square root of 18. Okay, so that's my answer. They do want us to simplify. Okay, so let me come up here. The question is, can it be simplified? Well, yes. 18, we know that that is 9 times 2. And we know that the square root of 9 is 3. So the square root of 18 can be simplified to 3 square root of 2. Right? That's my value. Okay, it's very possible that in the solution you may need to type it as 2 different answers. 4 plus square root of 3, 4 plus 3 square root of 2 and 4 minus 3 square root of 2. I honestly am not sure. They may take it the first way with the plus and minus sign, right? But either of those are the answer. Okay, that's completing the square. I'm going to check your work to see. I will say, if we have a problem like this that asks you to complete the square on the test, and you solve this using the quadratic formula, you will get no credit, okay? Because this is particularly asking to use a certain method. I want to see that you know how to use the complete the square, okay? All right, so now we have a solve the radical equation. There's a square root sign. I'll zoom in a little bit. Okay, so when you get to this one, first of all, when you see the square root sign in the original problem, you might want to just make a note to yourself. This is one that you're probably going to have to check your answer. At the very end, we're going to have to check it. Because the way we're going to use this is to solve. We want to pull that x, or that 9x, out from underneath that radical sign. We've got to get it out from underneath there. Okay, and what you can do is, if you have a square root, you can actually square both sides. There, as long as you do it to both sides. Okay, and this will help you solve it. Now, I will say, by doing this method, it could produce a false positive as an answer. So that's why you have to check. Okay, but let's finish working it out. Go back to black. Okay, when you square the square root, it crosses those out, right? It all cancels. Just get the 9 minus 9x. The quickest way, right? That was the quickest way to get the x out from underneath that radical sign. And then on the right side, please don't make the mistake of just saying that's x squared and 9 squared. Like x squared and 9 squared. That is not. I will erase that, undo that. What it is x plus 9 times x plus 9. Okay, and you're going to have to FOIL that out first, outer, inner, last. So let's work it out. Okay, our first is x squared. Our outer is 9 times x. Our inner, right here, 9x. And our last, 9 times 9 is 81. So we have from here, you're left with a quadratic equation. And the way we always try to solve this is first bring everything to one side, leaving 0 on the other. So I'm going to subtract that left side. Let's see, I'll subtract a 9 from both sides, and I've got to add that 9x, right? Okay, see what we get. 0, which is what we want. Let's see what we have. That's what, 27x. And then 81 minus 9, 72. Now this does end up giving us kind of some large numbers, but this actually does factor, and it should factor. This would give us 72, lots of different options. It would be 3 times 24. All right, 3 times 24 equals 72. 3 plus 24 equals 27, so here we are. Let's set each factor equal to 0. For the first one, we get x can be negative 3, and the second one, x can be negative 24. Okay, 2 possible answers, but remember, we must check, okay? Like I said from the very beginning, there's a chance that we could have gotten a false positive, and one of these may not work, so let's make sure we check. And the way we check, we're just going to come, I'm going to move over a little bit to check. Let's start with negative 3. X equals negative 3. We're going to check it. You just take the original function, or the original equation, which was the square root of 9 minus 9x equals x plus 9. We're going to plug negative 3 in and see if it makes sense. I'll take it step by step, but you can do a lot of this maybe in your head. 9, let's say that's 9 plus 27, so what's that, 36? 6 equals 6. That makes sense, which means negative 3 is an answer, right? It's a credible answer. And then if we check negative 24, just to show you one, this one turns out to be a negative. Doesn't work, but let's check it just to show you. Okay, that's a kind of a big one, isn't it? 24 plus 9, we get, let's see, 9 times 24, oh, that is 216. So 9 plus, that gives me 15. On that side, and on the other side, a negative 24 plus 9 is negative 15. Okay, that makes no sense, okay, which means this was one of these false positives. Negative 24 does not work. You only get one answer, and it's negative 3. Usually I see this on the test where people work it correctly, but they forget to check and list both answers, you know, as the right solution. But it really is, it's only one answer, the negative 3. Okay, perform the indicated operations. This is going kind of backwards. We covered this before the equations, but it falls later in the bonus assignment. All they're wanting you to do is get common denominators and subtract the 2 fractions, combining it into one single fraction at the end. So let's get our common denominators. That would be, what, x plus 3 times x minus 3. We'll do both. This just requires a little bit of busy work and writing. Okay, let's convert each one. So our original fraction was x minus 1 over x plus 3. The new part was x minus 3, so whatever we put in the denominator, we have to include in the numerator. That's my first fraction. My second one, we had x plus 6. Originally, we had x minus 3, so x plus 3 is what is new in this one. Right? So now we've converted each individual fraction into one with the same denominator. Now that we have common denominators, we can combine them all into one. All right, so my common denominator, x plus 3, x minus 3. You really don't have to do anything with that the rest of the time. You just, for the numerator, you have to multiply each one out and then combine any common terms. So for my first one, let's you have to FOIL it out. You have first, outer, inner, and last. That one. Minus. Same thing with the second one. First, outer, inner, and last. Alright, so we FOILed each one out. One more step. I'm going to take a step and combine these middle terms. Just to give me an extra, just to simplify just a little bit. Okay, notice, please, please, please do not forget to keep these parentheses. They're very important, especially when you're dealing with a subtraction problem. Okay, we're almost there. Very important. This is where I've seen people miss. I have minus. Very important to have these parentheses. A lot of people want to leave those parentheses off. If you left that parenthesis off, then you would only be subtracting x squared. But here you're subtracting all three terms. You know, that whole polynomial there. So that's very, very important. Okay, so now we're getting really close to the end. We want to drop the parentheses, which means we're going to have to distribute the negative through, like that. Okay, and when we do that, we get, okay, minus x squared. You just change the sign. Minus 9x minus 18. And your final step is combine any common terms that you can. Right? X squared minus x squared, that actually gives you 0. We have negative 4x minus 9x, that gives you negative 13x. And 3 minus 18. And this is all they're asking for. Once again, they're not asking you to solve any equations. There's no equal sign like you're solving for x. They just wanted you to subtract the two fractions, getting the common denominator, and then putting it all together into one single fraction. So that's my answer. Okay, for this next one, simplify the rational expression. Find all the numbers that must be excluded. Okay, to simplify, you're just going to factor the numerator and the denominator, and hope that you have something common to cross out. So let's factor the numerator. We know 40 is 8 times 5. Right, so plus 8 minus 5 gives you 3. On the bottom, looks like we're going to choose the same 8 and 5, but this time both negatives, and that gives you negative 8, and negative 5 gives you negative 13. So we get it factored. You're looking for something common. Those cross out. So my simplified answer would be y plus 8, y minus 8. Okay? So let's see, that would be my that one. Okay, but they do say find the numbers that must be excluded from the domain of the simplified rational expression. Okay, for this one, you just want to be careful. Even though it says of the simplified, when you're choosing that from seeing what needs to be excluded, you look at the denominator, and even though the y minus 5 you crossed out, you still want to include that when you're figuring that out. So you just take the denominator, set each one equal to 0, and solve. Right? You want to find the values that make the denominator 0. So you get, what, 8 and 5. Right? So the two values that need to be excluded would be 8 and 5. They're the two numbers that made the denominator 0. please don't make the mistake of looking at your simplified answer over here. I've seen a lot of people that they set the top and the bottom equal to 0, get -8 and +8. That shows you don't understand at all. What we mean is, why do we have to even exclude something? We have to exclude the values that make the denominator of a fraction 0, because you can never, ever, ever have 0 in the denominator. You can in the numerator all you want to, but not the denominator. Okay? So just don't forget, include the one, even the one that was crossed out, 8 and 5. Okay. Right, the last two I wanted to do are these complex fractions. Like I've shown people in class, and I made a video about it, I like to use a shortcut method. So my shortcut method simply says, Pearson doesn't work it this way. If you're working it, getting Pearson to help you solve one of your homework problems, it would show you a little different method, which is perfectly correct. But this is a shortcut. And the shortcut basically says this: you're going to find a value that's common to all of the fractions, right? We have two little individual fractions, 1 over x and 1 over x squared. Find a common denominator to that, which in this case, what's common would be x squared. And so what you're going to do is you're going to multiply by the fraction by x squared over x squared, which is like multiplying by 1, right? So you haven't changed the ratio of the fraction. That has to be distributed through. So basically, you're going to multiply everything by x squared. So when I approach this from the beginning, I'm just going to recopy it. My shortcut method is that I take my common denominator, right? I'll use blue this time. Okay, and I'm going to multiply everything by x squared. Multiply that by x squared. Got to multiply each term. Hope that makes sense. As long as you multiply everything by x squared, you're okay. That's the same thing over here as saying x squared right there. You're distributing it through. Okay. When you do that, you can cross out x, and x crosses out and leaves you an x. So in the numerator, let's see, I'll go back to black. We get 1 times x. No denominators. And in the bottom, those cross out and leave you 1 for x squared. So in one step, the shortcut, if you want to use that, you certainly can. That helps simplify and get rid of the individual fractions. Now this can still be simplified a little more, so let's see, I'll do it down here. The numerator can be factored. And then the denominator, if you look over here, if you can recognize, this is a difference of it's a minus. A difference of 2 squares, like that. So it actually can be factored into plus 2x, 1 minus 2x. Those cancel. My final answer, simplified answer, would look like that. Okay, once again, I'm using a shortcut method. Pearson shows you a little different method, which is basically saying just combine the top fractions into one fraction and the bottom, and then divide the two. It's the same thing, just maybe an extra step. Okay, and to finish up, I just want to work another one just to repeat, showing you the shortcut method. This is just like the last one I worked. Here you have 4 individual fractions, and my shortcut method is to find something that's common to all 4 denominators, right? So I have a w and x, a w, x, so I'm going to pick wx, okay? As a matter of fact, I think I'm just going to erase that again. We'll start from here. So my shortcut method says, basically, I'm going to do blue, multiply everything by wx. Here, I'm running out of room, so let me recopy it and give myself a little more space. Okay, you of course could just jot this down with your pencil, but I'm going to spread out a little bit. Okay, so I recopied it. So the shortcut method is pick something common, right? wx, wx. We're going to pick w times x. Multiply every term, every one. You're okay as long as you do everything. So by doing that, now let's start crossing out. The w's cross out, the x's cross out. So here, those crossed out, I get 3x, 5w, that's the top. Those crossed out, w. And you are done. Okay? Don't make the mistake when you see this final answer to think that you can start crossing out x's and w's. Remember, you can't cross out those. The only time you can start crossing things out from the numerator and the denominator is when everything's being multiplied. And that plus and that minus keeps you from being able to simplify. That's your final answer. Okay, I hope that helps. This is, once again, I didn't work every single problem, but I did work at least one of each kind that you would see. Hopefully this helps in preparing for your test 1.